Welcome to the class. So this is the first lesson of the module TETC 2112 Calculus 2, and this is 2 credit module. So as this is the first class, I'm not going to discuss the theories related to this module, but the necessary basic mathematics for this to follow this module. So let's go through with the topic that we are going to discuss for today. So it is partial fraction decomposition. So before moving to the theories and techniques of partial fraction decomposition, I will explain the idea. So what is the idea that we are supposed to discuss under this partial fraction? So let's see. Um, generally, if let's consider two fractions. So let's see, we have two fractions as 3 over 5, 3 over 5 and plus 1 over 5. So if we have to add these two fractions, 3 over 5 and 1 over 5, so the thing that we are going to do is we need to check the denominator first. So here the denominator is same. Since the denominator is same, we can keep the denominator as it is and consider the addition of the numbers in the numerator. So with that we can obtain the answer as 4 over 5. Similarly, so let's see one more example. If we have to add 1 over 2 and 1 over 3. So if we have this type of case, then to add these two fractions, we need to, here also we need to consider the denominator first. So here we can see that the denominator is not same for those two fractions. So we are going to take a common denominator. So that common denominator, in most cases, we are obtaining this common denominator by multiplying the numbers in these two fractions. So the common denominator becomes 6. So the values of the numerator. So since to obtain 6 from 2, we need to multiply this by 3. So that we need to multiply this also by 3. So here to convert this 3 into 6, we need to multiply this by 2. Then we need to multiply the numerator is also by 2. So we can obtain 3 plus 2. So with that we can obtain the answer as 5 over 6. So this is the way of adding two fractions. So let's consider something complicated two fractions than these two. So let's see, I'm going to use some rational expressions which consist of some variable. So let's take an example as I'm going to consider 2 over x plus 1 plus 1 over x plus 3. So let's see, we have to add those two fractions. So here also we need to follow up with the same procedure. So first we need to check the denominators. So here the denominators are not same. So we have to consider the common denominator. So as I mentioned earlier, to obtain the common denominator, we can multiply the numbers in the denominator. So we can obtain this as our common denominator. So to convert this part into this, we are multiplying this by x plus 3. So that means we need to multiply this numerator also by x plus 3. And here we multiply this by x plus 1. So we need to multiply the numerator is also by x plus 1. So we can obtain our numerator as 2 times x plus 3 plus 1 times x plus 1. Then we can simplify. So 2 times x plus 3. 2 times x is 2x. 2 times 3 is 6. 6. 1 times x is x. And 1 times 1 is 1. So we are dividing this by this, our common denominator. So we can obtain the answer as we have the common denominator x plus 3, and in our numerator we have to add the similar terms. 2x plus x is 3x plus 6 plus 1 is 7. So we can obtain this one as the answer. So if we start from this one, that means we have started it from, so let me erase these things and rewrite. Shall we write it again? So we are starting from 2 over x plus 1 plus 1 over x plus 3. And we know that the method of obtaining this expression starting from this one. So we have to take the common factor and do some algebraic simplification. With that, we can obtain this expression from this one. So the thing that we are going to learn for today, that means the partial fraction decomposition, means we are going to starting from this stage. We are going to starting from this stage. We are going to starting from this place, and starting from this, we are going to obtain this one. So that this process we call the process of obtaining this one from this one, we call this as the partial fraction decomposition. Okay, so let's go through with the techniques and what are the things that we need to follow when we are applying this partial fraction decomposition. So you can go through with this note. So it is also stated the same case, the theory that I have explained earlier. So under this partial fraction decomposition, we are going to discuss 4 specific cases. So the 4 specific cases means these cases are related to the denominator and the numerator of the specific rational function that we are going to consider. So before moving to these cases, I will explain that. So let's see, as earlier, we can see that if we have some expression, so in our earlier example, we have obtained the answer as 3x plus 7 over x plus 1, x plus 3. This is equals to 2 x plus 1 plus 1 x plus 3. So this is our earlier case, the case that we have considered earlier. So here, let's see, we have an expression of this form. So we are generally writing it as px over qx form. Px over qx form, if we have a formula in px over qx form, and we are going to discuss 4 cases of obtaining the 4 cases of writing expression to obtain partial fractions according to the polynomial in this denominator. That means according to the polynomial of according to this qx polynomial. So the first thing that we have to do when we are asking to find the partial fractions is, first we need to factorize this polynomial qx. That means the polynomial in the denominator. So as the first step, we need to factorize the polynomial qx. That means we need to find the factors of the polynomial qx, and then according to the factors, we are going to write the expression to find the partial fraction. So, and that stage we need to proceed 4 cases. So let's discuss each cases separately. So the first case that we're going to consider is if we have an expression px over qx form, and here if this qx has only non-repeated linear factors. So this is the important thing here. It has only non-repeated linear factors. So you have to be careful with these things. Here there are two conditions. The first condition is there should be linear factors, and the second condition is those factors should be not repeated. So if we have a fraction px over qx form, and then this polynomial qx has non-repeated linear factors, then we can write the expression to obtain the partial fractions in this manner. So here we are writing this formula as in generally I will write it here. So if we are considering this polynomial qx, and if we have obtained the factors of this polynomial qx as, I will write it here. So let's see, the factors are a1x plus b1, a2x plus b2, anx plus b. So that means these are linear factors. Linear factors කියන්නේ ළමයි මේ වගේ සාධකයක x ගේ බලය එක වෙච්චි fact එකක්. So the linear factors means a factor which is the degree, which is the power of the term x should be equals to 1. So we can identify those type of factors as linear factors, and the linear factor should not be repeated. That means there cannot be two same factors in this polynomial. ඒ කියන්නේ factor එකෙන් factor එකට එකිනෙකට එකක් වෙනස් වෙන්න ඕනේ. එකම දෙතුන් පාරක් appear වෙන්න බෑ. So if we able to factorize qx in this manner, that means only with linear factors and those factors are not repeating. So we can write the expression for partial fractions as this way. So a1 over the first factor, a2 over the second factor, a3 over the third factor, and an over the nth factor. So here this a1, a2, a3 and a4, all these values are constant. So here you have a1, a2 up to an, all these are constant, and the thing that you need to do here is we need to find the values of these constant, because since these a1 these are factors, this simple a1 b1, simple a2 b2, simple an bn, those values are something known. We know the values of simple a1 a b1, a simple a2, simple b2, those things. But here this a capital A1, capital A2 up to capital A, those things are something new that we are going to put. So we need to find the values of this constant. So let's see what is the procedure that we need to follow to find these values of these constants. So here, this is the steps that we going to follow, that we need to follow. So I will do an example, then you can get the idea what is the procedure of doing this type of example. So let's see, let's starting from this example number 1. So here we have a problem. So let me So we have a problem. They are asking to decompose the rational expression with distinct linear factors. So let's starting from this one. So here we can identify this as our px, and this is the qx. And here if we consider the polynomial qx, we can see that it has only linear factors. That means there are two factors, and each factor, the power of x is 1. So these two are linear factors, and then since these two are linear factors and it is not repeating, so we can identify this as our, this problem follows our case 1. So we are going to solve this problem according to the theory related with case 1. So I will write the problem first. So we are going to find the partial fractions of 3x over x plus 2, x minus 1. So I will go back with the theory part. Here we can see that if we are asking to find the partial fractions of case 1, so we can see that here we need to write the expression to obtain partial fractions. So we are going to write this type of expression for our example. So let's see how we do that. So as the first step of finding the partial fractions of this type of example, first thing that we need to do is we need to write the expression related to the partial fraction. So we are going to write, if we have px over qx type of function and linear factors and they are not repeating, so we are going to write this expression to obtain partial fractions according to the case 1. So we can write, so let's see, an unknown constant a over the first factor and then plus another unknown constant over x minus 1. This is our second factor. So this is the first step of obtaining partial fractions, and here you have to be careful with you have to be careful when you are writing this expression, and the thing that you need to careful is you need to identify what is the case. Is it case 1, case 2, case 3 or case 4? So according to the case, the way of writing this expression is varying. So since this is a case 1, so we are writing this formula in this manner. So once we have obtaining this expression, the thing that we are going to do is we are going to multiply both sides of this expression by the polynomial qx. So our polynomial qx is x plus 2, x minus 1. So we are going to multiply the both side of this expression by this polynomial. So I will write it here. So let's write, we have 3x over x plus 2, x minus 1, and we are going to multiply this by x plus 2, x minus 1. This is equals to a over x plus 2, and we are multiplying this by x plus 2, x minus 1, and then plus b over x minus 1, and we multiply both. This is also by this polynomial. So and then we can say that this x plus 2 to this x plus 2 cancel out, this x minus 1 to x minus 1 cancel out, here this one to this one cancel out, this one to this one cancel out. So we can write the remaining expression. So in this left hand side, 3x is the only remaining part. In the right hand side, a times x minus 1 plus b times x plus 2. So that is the expression that we have obtained by multiplying both sides by this polynomial qx. So this is the next stage. And then the thing that we need to do is we need to find the value of this a and b. These two are some unknown constants. So to find the values of this a and b, so you can substitute any value for x. With that, you can obtain some equations with two variables, and by solving those two equations, you can obtain the answer. So starting from, so I'm going to substitute x is equals to 1. If we substitute x is equals to 1, then in our left hand side, we can obtain it as 3 is equals to a times, we are putting x is equals to 1 minus 1 plus b times 1 plus 2. Since 1 minus 1 is 0, this whole part goes to 0, and so that we can obtain 3 is equals to 3b. So by dividing both sides by 3, we can obtain b is equals to 1. So we have found the value for the constant b, and still we need to find the value of a. So to find the value of a, let's put x is equals to minus 2. So if we put x is equals to minus 2, in the left hand side, we can obtain 3 times minus 2, that is minus 6. This is equals to a times minus 2 minus 1 plus b times minus 2 plus 2. And here minus 2 plus 2, it is 0. So this part becomes 0. So we can obtain an expression as 6 minus 6 is equals to minus 3a plus b times 0. So since this part goes to 0, we can divide both sides by minus 3. With that, we can obtain a is equals to 2. So we have obtained the value for a and b. So once you have found the value for a and b, we can obtain the partial fractions by substituting the respective values that you have obtained into this expression. So we can write the final answer as the fraction that we are asking to find the partial fractions is 3x over x plus 2 x minus 1, and this is equals to the value of a. The value of a that we found is 2 over x plus 2 plus 1 over b, because the value of a is 2 and the value of b is 1. So with that, we can obtain this as the answer for the first example. I hope this is clear to you, and then you can practice this example number 2. So I will write the answer for this example and try to obtain that answer by yourself. So the problem is x over x minus 3, x minus 2. So the partial fractions, once you have go through with this procedure, you will obtain it as minus 2 over x minus 2. So this is the answer that we have required. It's the answer that you required. So try to obtain this by yourself. So this is the case 1. In the second case, so the second case, this is also a specific case, and here in this case, this is also we consider px over qx form, and the most important thing is this qx has repeated linear factors. That means the factors should be linear factors. That means the power of x should be 1, and if there are some repeated factors, that means the factors are appeared more than once. A specific factor which is appeared more than one, then we need to follow up with this case 2. So here, let's see how to write the formula. And here we can see that the expression is the partial fraction decomposition of px over qx when qx has the repeated linear factor occurring n times and the degree of px is less than the degree of qx is. So we can write the obtain the expression to obtain the partial fractions in this manner. And here, so we consider the polynomial qx. We consider the polynomial qx as there is a linear factor ax plus b and it is appeared n times. So the polynomial qx is appeared as ax plus b to the power n formula. So we can write the expression as ax plus capital A1 over ax plus b, capital A plus A2 over ax plus b to the power 2 and uh, A3 over ax plus b to the power 3 and A4 over ax plus b to the power 4, so on. So that means here the most important thing is you need to write this expression according to the ascending order, increasing order of the powers. So let's see here also. Let's see how to write this type of expression and you do an example when I explain in the example. But here the most important thing that you have to remember is you have to write the denominator powers according to the increasing order. So let's see what is the steps and the process of solving this, doing this type of problem. So here the steps were given here, but the set of steps are same according to the earlier case. And here also, here the thing that you need to remember is first you have to identify the types of factors in the polynomial in the denominator. So let's go through with this example. Let me add the page. So this is the example that we're going to follow up under the uh, second case. So I will write down the example first. The example that we're going to consider is minus x squared plus 2x plus 4 divided by x to the power 3 minus 4 x to the power 2 plus 4x. So this is the example that we're going to consider. And as I mentioned earlier, the first thing that we need to do is we need to factorize the polynomial in the denominator. So here we can see that if we consider this polynomial, the polynomial in the denominator, that means we are going to consider this polynomial. If we consider this polynomial, you can see that there is a common factor. So if we take this common factor x out, the remaining part is x to the power 2 minus 4x plus 4. And then we have to factorize this part as well. So we can obtain this is the x minus 2 to the power 2. So we have obtained the factors of the denominator and we can see that there are only linear factors. This is a linear factor, this is a linear factor, and this is not repeating. Since there is the second power, this part is repeating. So since this first factor is not repeating, it is under the case 1. Since this is repeating, this is under the case 2. So let's see how to write the expression of obtaining the partial fractions of this example. So our numerator is x to the minus x to the power 2 plus 2x plus 4, and the denominator, the factors are x times x minus 2 to the power 2. Those are the factors, and we can write the expression to obtain the partial fractions according to the each case. Since the first factor is according to case 1, we can write a constant a over the respective factor. The factor is just x. And then since this x minus 2 to the power 2 is follow up with the case 2, we are going to write the expression as b over first power of the factor and then another constant over the second power of the factor. So once we have obtained this expression, this part, we have obtained this part from case 1 and this part, this entire part from case 2. So once we have considered these both cases separately, we can write this expression. So once we have obtained this expression, we are going to multiply the both side of this expression by this polynomial qx, x times x minus 2 to the power 2. So I'm not going to write the expression again. So if we multiply this entire thing by this thing to this thing cancel out, and the remaining part of the left hand side is minus x to the power 2 plus 2x plus 4. This is equals to, and here we multiply this thing by this factor by this one. So we can see that this x to, we can see that this x to this x cancel out, and the remaining part is, what's the remaining part? A times this thing. So we can write the expression as a times x minus 2 to the power 2. And here we are going to multiply this one by this. And we can see that this one to one of this factor is cancelled and remaining part is x times x minus 2. So we can write the expression as plus b times x minus 2. And then as the last part, we are going to multiply this by this, and this entire thing to this entire thing cancel out. The remaining is c times x. So we can write c x. So once you have obtained this expression, you can substitute some values for x. With that, we can obtain the value of a and b by solving some set of simultaneous equation. So let's start from x is equals to 0. So if we substitute x is equals to 0 in the left hand side, minus 0 to the power 2 is 0, plus 2 times 0 again 0. So 4 is equals to a times 0 minus 2 to the power 2 plus b times 0, 0 minus 2 plus c times 0. And we can see that this is goes to 0, this part is also goes to 0, and the remaining is 4 times 0 minus 2. It's minus 2. Minus 2 to the power 2 is 4. 4 is equals to 4a. So by solving this equation, you can obtain the value of a as a is equals to 1. So once we have found the value of a, then we can substitute another value. We can let's substitute x is equals to 2. If we substitute x is equals to 2, then we can obtain minus 2 to the power 2 plus 2 times 2 plus 4 is equals to a times 2 minus 2 to the power 2 plus b times 2 minus 2 plus c 2. And we can see that 2 minus 2, this is equals to 0. And again 2 minus 2, this is also equals to 0. So this entire thing goes to 0. This also goes to 0. So we can obtain, and this side uh, it is minus 4 plus 4 plus 4. So this one to this one cancel out. The answer, the remaining is 4 is equals to 2c. So simplifying this, we can obtain c is equals to 2 as the answer for the constant c. And then there is another constant remaining, the constant b. So to find this constant, so if you need, you can substitute some value for x, and we already know the value of a and b. So by substituting value of a and b also, you can obtain the answer. So I will explain some other way of obtaining the constant b. So if we expand this expression x minus 2 to the power 2, we can obtain x to the power 2 minus 4x plus 4. And if we expand this thing as well, we can obtain x to the power 2 minus 2x. So, and here we are going to consider the coefficients of the variable. We are going to consider the coefficient of x square. So if we rewrite this, I will rewrite this expression so you will get a better idea. Earlier we had x to the power minus x to the power 2 plus 2x plus 4 is equals to a times x minus 2 to the power 2 plus b times x minus 2 plus cx. And if we expand these two, we can rewrite this as a times x squared minus 4x plus 4 plus b times x squared minus 2x plus cx. And here minus x squared plus 2x plus 4. And then since these two statements are equal, then see, if there are two statements are equal, then the terms in the left hand side and right hand side should be equal. So if we consider the coefficients of x to the power 2, we are going to consider the coefficients of x to the power 2. The coefficient of x to the power 2 in the left hand side is, this is minus 1. So this is minus 1. And in the right hand side, so if we multiply this by this, then we have the coefficient of x squared as a. And if we multiply this by this, again we have the coefficient of x squared as b. And there is no other x squared term. So we have obtained, by considering the coefficient of x to the power 2, we obtain the equation a plus b is equals to 1. So we have found the value for a earlier. The value for a is equals to 1. So this is minus 1 is equals to 1 plus b. So by solving this equation, we can obtain the value of b as minus 2. Once we have obtained the values of all these three constants, we can write the answer. The problem that we have to find the partial fractions is this one, x plus 4 over x to the power 3 minus 4x to the power 2 plus 4x. So the value of a is 1 over x. Value of b is minus 2. So minus 2 over x minus 2. And the value of c is 2 times x minus 2 to the power 2. So this is the answer for this example. So I hope this is clear to you, and I need you to practice this example. So I will give the answer for this as well. Then you can check whether your answer is correct or not. 6x minus 11 over x minus 1 to the power 2. So you will obtain the answer as x6 over x minus 1 plus, not plus minus 5 over x minus 1 to the power 2. So try to obtain this answer by yourself. So this is the case 2. So then we can move to the case 3. So here the case 3, we are considering px over qx type of expression, and the qx, the polynomial qx, the polynomial in the denominator, it has non-repeated quadratic factors. So the quadratic factors mean a factor with power 2. The factor with power 2. So that means, as an example, we can write ax squared plus bx plus c. So this type of factor, and it should be not repeated. So the major difference between case 1 and case 3 is, in the case 1 we are considering the linear factors, and in the case 3 we are considering quadratic factors. And in both case 1 and case 3, the factors should not be repeated. So the way of writing the expression for the partial fractions for case 3 is this manner. So that means we are going to consider non-repeated quadratic factors. So we can write the denominator as a1x plus b1, a2x plus b2, anx plus bn, likewise. And here this constant, capital A1 b1, a2 b2, capital A2 b2, an bn, those things are some unknown constant, and we are asking to find those constant. So that is the thing that we are going to do under this case 3. So let's see, these are the set of steps, and we are going, as the earlier cases, similarly we are going to follow the same process. The only difference with these earlier cases is the way of writing the expression to obtain the partial fractions. So let's do this example, then you will get a better idea to do this type of example. So I will add. Okay. So let's see this example. The example that we are going to consider is 8x to the power 2 plus 12x minus 20 over x plus 3, x squared plus x plus 2. This is the example that we are going to find the partial fractions. So here, let's consider the polynomial in the denominator. And here we can see that there are two factors. The first one is the power of x is 1. So this is a linear factor, and this factor here we can see that the highest power of x is equals to 2. So this is a quadratic factor. So, and we can see that these factors are not repeating. So this first factor follows the case 1, and the second factor follows the case 3. So let's see how to write the expression of this type of example. Since this first factor follows the case 1, we are going to write the expression according to the case 1 for first factor. So we can write some constant over this factor x plus 3. And then, since this second factor follows the case 3, we are going to write the expression according to case 3. So we can write it as bx plus c over x to the power 2 plus x plus 2. So this is the way of writing the expression for partial fractions. And here also, as the next step, we have to multiply both sides of this expression by the polynomial qx plus 2. So then we can obtain, if we multiply this side by this one, the remaining thing in the left hand side is 8x plus 2x squared plus 12x minus 20. And if we multiply this first fraction by this one, we can obtain a times x to the power 2 plus x plus 2. Then if we multiply this entire thing by this thing, you can obtain bx plus c times x plus 3. And here you have to be careful. You need to put this bracket, you need to put this parenthesis, otherwise your expression will be wrong. If we do not put this parenthesis, then maybe you will think you are only multiplying this expression by c. So, but we have to consider the product of this entire thing by this thing. So you need to put this parenthesis. Okay, so once you have obtained this expression as earlier, we are going to substitute some values, or we are going to consider the corresponding components. With that, we can obtain the answer. So let's see. First, let's put x is equals to 0. If we put x is equals to 0 here, we can obtain in the left hand side, it's minus 20. And here 0 plus 0 plus 2. So 2a b times 0. So this part becomes 0 and c is remaining. And here if we put 0 here, 0 plus 3 is 3. Here we can obtain a plus 2a plus 3c is equals to minus 20. So we can label this as equation number 1. And then we are going to consider the coefficient of x to the power 2. So the coefficient of x to the power 2 in the left hand side is 8. And the right hand side, if we multiply this a by this thing, we can obtain the coefficient of x squared as a. And then if we multiply this with this, we can obtain the coefficient of a as coefficient of x squared as b. And we can obtain this as our second equation. And we are going to substitute the value. Let's substitute x is equals to minus 3 into both sides. So if we substitute x is equals to minus 3, we can obtain 8 times minus 3 to the power 2 plus 12 times minus 3 minus 12. This is equals to a times minus 3 to the power 2 plus minus 3 plus 2 plus b times minus 3 plus c, this whole thing times minus 3 plus 3. Since minus 3 plus 3, this part becomes 0 if we multiply this entire thing by 0. So this whole thing goes to, this whole thing is product of these two things is equals to 0. So once we have simplified this expression, 3 to the power 2 is 9. 8 times 9 is 72 plus 12 times minus 3 is minus 36 and minus 20. This is equals to a times minus 3 to the power 2 is 9 minus 3 plus 2. So you will obtain 16 is equals to 8a. So that means a is equals to 2. So once we have found the value of a, so you can find substitute the value of a into this equation number 1 and equation number 2, and then we can obtain the answer for b and c as well. So starting from equation number 2, if we substitute a plus a by 2, so 2 plus b is equals to 8. This provide b is equals to 6. And equation number 1, we have obtained minus 20 is equals to 2 times a. So 2 times 2, 4 plus 3c. So this provides c is equals to minus 8. So once you have identified the value of a, b, and c, you can write the final answer by substituting the respective values as 8x to the power 2 plus 12x minus 20. This is divided by x plus 3 over x squared plus x plus 2. This is equals to our a. Value of a is equals to 2. So 2 times 2 over x plus 3 plus, and b, the value of b is 6 x, and c is minus 8 over x squared plus x plus 2. So this is the answer for this example. So I hope it is clear to you. And so once you have identified the concept, I need you to try this example as well. So I will write the answer. The partial fractions of this example is 3 over x minus 1 plus 2x minus 4 over x squared plus 1. So try to obtain this answer by yourself. Okay, so let's move to the last case, case number 4. So here also we are going to consider a rational expression px over qx form, and here this qx has quadratic root, quadratic factors, and the most important thing is those if the quadratic factors are repeated. So as the case 2, in the case 2, we are consider linear factors, and those linear factors are repeating, and here we are considering quadratic factors, and those quadratic factors are repeating. So let's see how to write the expression. As earlier, we are starting from, we are going to consider a repeated quadratic factors. There are n, let's see, n repeated quadratic factors. So then we can write the first fractions as ax squared plus bx plus c to the power 1, and the numerator there should be a1x plus b1. And the second factor, the denominator is ax squared plus bx plus c to the power 2, and this thing. Similarly, we need to write this n times since there are n repeated factors. And then here also, as in the second case, here also you need to write this expression according to the increasing order. According to the increasing order. Otherwise, you will your answer is not, if it is not correct, but it will be something complicated while you are obtaining the answer. So here also we need to follow up with the same steps, and the only difference is obtaining the expression. So let's do this example. So starting from this example, first I will state the example. So we are going to consider the example x to the power 4 plus x to the power 3 plus x to the power 2 minus x plus 1 over x times x squared plus 1 to the power 2. And here we can see that there are three factors. This one and this is repeated twice. And this is, the first factor is a linear factor and this is a quadratic factor and this is not repeating and this is repeating. So we can see that this is from case 1 and this is from case 5. Since it is a quadratic factor and repeating, it is from case 5. So we are going to write the expression to obtain the each factor. So since the first factor follows the case 1, we can write a over x. And the second case follow the case 4. We need to write bx plus c over x squared plus 1 to the power 1 and dx plus e over x squared plus 1 to the power 2. So this is the way of obtaining this expression. And as earlier, we are going to multiply the both side of this expression by x times x squared plus 1 to the power 2. We are going to multiply both side of this expression by this thing. And we can obtain x to the power 4 plus x to the power 3 plus x to the power 2 minus x plus 1 a times x squared plus 1 to the power 2 bx plus c times x squared plus 1 and dx plus e times x. So to make our simplification easier, let's expand these expressions. So if we expand this thing, we can obtain x to the power 4 plus 2x squared plus 1. And if we expand these two, x to the power 3 plus x. And then let's write the expression by simplifying all the terms. X to the power 4 plus x to the power 3 plus x to the power 2 minus x. So if we substitute some values and obtain in the equations for this type of case, you will obtain several number of equations with 5, since there are 5 unknown terms a, b, c, d, e. So you need to find the value of these 5 unknown terms. So to obtain the answers for 5 unknown terms, you need at least 5 equation. So it will be much complicated if we substitute some values and obtain the answer. So it is better to go through it by considering the corresponding coefficients for this type of case. So let's write the expression. This is equals to a times x to the power 4 plus 2x to the power 2 plus 1 and let's multiply each part separately. If we multiply bx with x to the power 3, we can obtain b x to the power 4 and bx with x. It is b x squared plus c x to the power 3 plus cx plus the last part d x to the power 2 plus e x. Okay. Now we can start from the each cases and obtaining the respective answers. So starting from, let's start from x is equals to 0. So x is equal to 0 means the terms which is independent from x. So that means constant term. So here if we substitute x is equal to 0 here, this is 0, this is 0, this is 0, this is 0 and the remaining part is 1. So here if we substitute x is equal to 0, this part 0, this part 0 and 1 is there. So we can write a times 1 This is 0, this is 0, this is 0, this is 0. So this entire thing is equals to 0, and here d times 0 and e times 0. Again, it is 0. So we can obtain our a is equals to 1 by considering x is equals to 0. Okay, now consider x to the power 4, the coefficient of x to the power 4. So here the coefficient of x to the power 4 is 1 in the left hand side. In the right hand side, it is a, and we need to check there are another x to the power 4 terms. So here we can see that there is another x to the power 4 terms. So we can write plus b. Since we know the value of a is equals to 1, so 1 is equals to 1 plus b. So by solving this one, we can obtain b is equals to 0. So we have obtained the second value as well. And then let's see x to the power 3. X to the power 3. Here the coefficient of x to the power 3 is 1. And here there are no x to the power 3 terms. And here we can see that there is one x to the power 3 term. So we can see that this is c, and there are no other x to the power 3 terms. So we have obtained the value of c is equals to 1. And let's consider x to the power 2. And here the coefficient of x to the power 2 is 1. And here there are 1 x to the power 2 terms. So 2 times a, and here plus b. And there is another x to the power 2 here, t. And then substitute the values that we have obtained for a, b for this equation. So 1 is equals to 2 times 1 plus 0 plus d. So by solving this one, we can obtain d is equals to minus 1. So we have already found the answer for A, B, C, and D. And the E is remaining. So to find it, we can use, we can consider x, x coefficient of x, or else since we already know the value of 4 coefficients, you can, if you need, you can just substitute some value for x and obtain the answer for E as well. So let's consider the coefficients. So it is minus 1 is equals to, here there are no x terms. Here we can see that one x term is there. So c plus there is another one x term, c plus e. And we know the value of c, it is equals to 1 minus 1, 1 plus e. So e is equals to minus 2. So once you have obtained all these values, you can just substitute those values and write the answer. The expression is equals to, our a is equals to 1 over x. Since the value of b is equals to 0, bx plus c, 0x plus 1. So the remaining is 1 over x squared plus 1, and dx plus e. So it is minus x minus 2 over x squared plus 1 to the power 2. So we can rewrite this as 1 over x plus 1 over x squared plus 1. Since this minus is common, we can bring it out and write x plus 2 over x squared plus 1 to the power 2. So this is the answer for that example. And there is also there is one more example where they are. So I need you to practice this one as well. So try to obtain the answer. I will write the answer. This is the partial fractions are x minus 2, x minus 2 over x squared minus 2x plus 3 plus 2x plus 1 over x squared plus minus 2x plus 3 to the power 2. So try to obtain this answer by yourself, and there are some more practice problems in the lecture slides. Please practice those problems as well, then you will get the better idea. So as a summary, so I will summarize all the things that we have learned so far. So the first thing, so I will just, okay, as a summary, we have an rational fraction of the form px over qx. So according to the factors of this qx, we can identify four cases of partial fractions. The first one is qx has linear factors but not repeating. These are the second case. The factors are linear and they are repeating. And the third case, the factors are quadratic factors and them not repeating. And the fourth case, the factors are quadratic and it is repeating. So uh, that is the first case. First, you have to identify the types of factors of qx. They are linear or quadratic, repeating or not repeating. So according to these the repeatance and the uh, linear and quadratic type of a factor, we can identify what is the suitable case that we need to follow up with. So once you have identified the suitable case, write the expression according to that case, and then multiply both sides by the polynomial qx. With that, you can obtain an expression. And by substituting some set of values or considering corresponding components, you can find the values of the constant that you have found the value. So that is the summary of doing this type of problem. So I need you to go through with this set of practice examples and try to obtain the answers. So that is the first section, and thank you.